Okay, hi everybody. This is the Math 31 applications review, and this is question number 2. It says two particles have displacement functions respectively, and they're given in the question. We want to find their accelerations at the instant that their velocities are equal. Okay, so really the defining feature here, the thing that we got to work on, is that their velocities are supposed to be equal. So what I got to do is I got to find their respective velocities. So v1 is going to be the derivative of the first displacement function, which in this case will be 12t squared plus 12t minus 12. Well, that's kind of nice. A whole bunch of 12s there. The second velocity function, okay, will be the derivative of the second displacement function, and that is going to be, when I take a look at that, what will that be? It'll be 6t squared plus 60t minus 84. Okay, so now what I'm supposed to do here is set these two terms equal to, these two expressions equal to each other. Okay, so 12t squared plus 12t minus 12 is equal to 6t squared plus 60t minus 84. And I'll solve for t here. Now the nice thing is this is really just going to end up being a nice little quadratic. Okay, so I'll bring that 6t squared over, and I'll get 6t squared here. I'll subtract the 60 from both sides, and I'll be left with a negative 48t on this side. And then I'm going to add 84 to the other side, and that's going to leave me with a positive 72, all equal to 0 on the left-hand side here. Now, nice thing is everything here is divisible by 6, so t squared minus 8t plus 12 is equal to 0. And I can factor that down. Okay, and I will get, what's that going to be? Well, it's going to be negative 2, negative 6. Okay, so this occurs at the two values of time here where t is equal to 2 and t is equal to 6. Those are the places where the velocities are the same. Now, what I'm supposed to do is figure out the accelerations. So to figure out the acceleration of the first expression, I will take the derivative of the first velocity function, and that will be 24t plus 12. Okay, and so now what I'm supposed to do here is evaluate this at the instant when they're the same here. So this is going to be, what we'll do here is a1 evaluated when x is equal to 2. And so we're going to get 2 times 24 plus 12. Okay, and that's 60. Or we're going to get a1 evaluated when x is equal to 6. I want to run off the page there. And that's going to be 24 times 6 plus 12, which will get us 156. Now, I don't know what the units are specifically. I don't think it says in the question here, so that's about the best I can say. It'll be units per units squared. The acceleration of the second function will be the derivative of the second velocity function, which in this case will be 12t plus 60. And so the acceleration of the second function evaluated when x is equal to 2, okay, will be 12 times 2 plus 60. So that'll be 84. And then that second function evaluated when x is equal to 6 is going to be 12 times 6 plus 60 is going to equal 132. And there you go. Those are their respective accelerations.